factoring trinomials of the form ax squared plus bx plus c. Our opening slide is of First Peoples Buffalo Jump State Park near Great Falls, Montana. At this cliff, many years ago, before they acquired horses, Native Americans would drive buffalo over the cliff and then harvest the injured and killed buffalo who fell to the bottom to use to provide food, clothing, and shelter. Before we start factoring, let's look at a couple of examples of multiplying binomials. We'll start with x plus 2 times x plus 3. We multiply the x by every term in the second parentheses. So we have x times x, which is x squared, and x times 3, which is 3x. Then we multiply 2 by every term in the second parentheses. So we have 2 times x, or 2x, and 2 times 3, which is 6. Then we collect like terms. There's only one x squared term, so we bring that straight down. But we notice that 3x and 2x are like terms because they have the same variable to the same power. So we add 3x plus 2x and get 5x. Then we bring the 6 down. The numbers 3 and 2 are factors of 6 that add to get 5. Here's another example. X plus 2 times x minus 3. We have x times x, which is x squared, and x times negative 3, which is negative 3x. Then we take 2, multiply times x to get 2x, and times negative 3 to get negative 6. Once again, we collect like terms. Negative 3x plus 2x is negative x. And we bring the negative 6 down. This time, the numbers 3 and 2 are still factors of 6. Since the 3 is negative, we got negative 6 in our answer. When we add a positive and negative number together, we subtract to get the answer and take the sign of the biggest number. Factoring trinomials is just reversing the process of multiplying binomials. We'll use as our example x squared plus 7x plus 10. If it factors, it will take this form. We'll have x in parentheses plus or minus some number times another x in parentheses plus or minus some number. We need factors of 10. So we list the factors of 10. We have 1 and 10, 2 and 5, 5 and 2, and 10 and 1. The factors need to add to get 7. Notice that we found the information we needed right in the expression. There was the 10, there was the plus that tells us add, and there's the 7, which is the number that we need. So we look down the list and we see that 2 plus 5 adds to 7. Either pair would work, 2 and 5 or 5 and 2. They both need to be positive. And here's the last bit of information. That plus sign right there tells us that they both need to be positive. So we put a plus 2 and a plus 5 in, and our factoring is complete. Notice again that we found all the information that we needed by moving right to left. To help remember what order to do things, we can remember a silly word, FATS. Factors of what? We always look for factors of the number on the right. Make a table of the possible factor pairs if you need to. Add or subtract. Moving right to left, the sign in front of the last term tells us if we add or subtract the factors. To get what? We add or subtract to get the middle term. Signs of the factors. If we added, then both factors have the same sign as the middle term. If we subtracted, then the largest factor has the same sign as the middle term. Notice we get the answer to all 4 of our questions. Factors of what? Add or subtract. To get what? Signs of the factors, by moving from right to left on the original problem. Another example. X squared plus 9x minus 10. If it factors, it will take this form. This is the same form we had last time. Factors of what? Work right to left. So we look down from the arrow and see that we need factors of 10. So we list the factors of 10. The next question is add or subtract. Once again, we look down and we see that we subtract. To get what? The information's right here. Look down and see that we get 9. So we look for factors that subtract to give us 9. And 1 and 10 work. The last question is, what are the signs of the factors? And we see from this plus sign that the biggest number is positive. Remember, because we are subtracting, 1 is positive and 1 is negative. So since 10 is the biggest number, 10 will be positive and the 1 will be negative. We put negative 1 on the left-hand side and plus 10 on the right-hand side. We keep the numbers in the same order that we started with. Now that doesn't matter so much in this problem, but in other problems it might. Here's one more example. X squared minus 6x plus 8. If it factors, it will take this form. Factors of what? Work right to left. We need factors of 8. So we list the factors of 8. Add or subtract? We add because there's a plus sign there. To get what? Keep moving right to left. And we see that we need to add to get 6. So we go down our list of factors till we find something that adds to get 6. 2 and 4 work. Signs of the factors. Since we're adding, the signs have to be the same. And this tells us that they're both negative. So we have -2 and -4. And we put those in the same order. So we have x minus 2 times x minus 4. If there is a number in front of the x squared term, then we have to expand the table. Our example is 3x squared minus 10x minus 8. This 3 in front of the x squared tells us that we can't just multiply x times x. We have to account for the 3 as well. So if it factors, it will take this form, because 3x times x gives us 3x squared. Now, the number that goes in the right-hand side here is going to get multiplied times 3, and the number that goes in the left-hand side is going to get multiplied times 1 when we multiply these back out. So we're going to write the coefficients of x in reverse order. Because 3 was on the left here, it goes on the right over here. And because 1 was on the right here, it's on the left in our table. Then we ask our questions. Factors of what? We work right to left, and we need factors of 8. So we list the factors of 8. We write the factors of 8 in the outside columns. We have 1, 8, 2, 4, 4, 2, and 8, 1. Do we add or do we subtract? We look at our expression, moving right to left, and that negative sign tells us that we subtract. To get what? Look up here. We want to get 10. So we subtract to get 10 after we multiply. So we multiply and look for a difference of 10. 1 times 1 is 1. 8 times 3 is 24. Those do not subtract to give us 10. So we move down. 2 times 1 is 2. 4 times 3 is 12. And those do subtract to give us 10. So we can stop there and move to our next question. Signs of the factors. Once again, looking at the expression, this negative sign tells us that the biggest will be negative. The 12 is negative, so the 4 must be negative. The outside numbers go in the equation. So we put in the 2 and the -4. Plus 2 minus 4. It's really important to remember that it's the outside numbers, not the answers to our multiplication, but the factors of 8 in this case, that have to go back into the equation. One more example. 6x squared minus 19x plus 10. It could factor as 6 times 1 or 3 times 2. We try one, and if it doesn't work, cross it out and try another. I'm going to try 3x and 2x. By the way, just a hint, Frequently in algebra books, it's better to pick numbers in the middle, not the ones on the outside like 6 and 1. The reason for that is the numbers on the outside generally tend to give you big numbers in your answer when you multiply them out. So textbook authors like to use the ones in the middle. We write the coefficients of x in reverse order. So it was 3 on the left and 2 on the right. Now it's 2 on the left and 3 on the right. Factors of what? We need factors of 10. So we list the factors of 10 all the way down, even in reverse order. So we have 1 times 10 and 10 times 1, for example. Add or subtract. We want to add to get what? To get 19 after we multiply. So we multiply and look for a sum of 19 because we're adding. 1 times 2 is 2. 10 times 3 is 30. These numbers do not add to 19, so we try again. 2 times 2 is 4. 5 times 3 is 15. These numbers do add to 19. We have one more question, signs of the factors. Because of this negative sign here, we see that both factors have to be negative. Because remember, we're adding, so they both have to have the same sign. So we have a negative 4 and a negative 15, which means what we put into our equation is a negative 2 and a negative 5. Once again, we remember to put the outside numbers back. Negative 2, negative 5. Here's another example without all the notes. 45x squared plus 42x minus 24. Don't forget to take out common factors. We always check for common factors first. So we can factor out a 3 because 3 goes into 45, 42, and 24. And we get 3 times 15x squared plus 14x minus 8. Now we make a guess at how we're going to factor 15. So my guess is 5 times 3. We put the numbers for our table in reverse order. So we have 3 and 5. Then we list the factors of 8. And we see that we want to subtract to get 14 after we multiply. So we start multiplying. 1 times 3 is 3. 8 times 5 is 40. And those do not subtract to give us 14. 2 times 3 is 6. 4 times 5 is 20. And those do subtract to give me 14. So since we're subtracting, the signs are different. So we look here and see that the biggest one must be positive. So the 20 is positive, the 6 is negative, which means we have a negative 2 and a positive 4. We put the outside numbers into the expression. So we have negative 2 on the left, positive 4 on the right, and there's our answer, 3 times 5x minus 2 times 3x plus 4. What's nice about this is that we don't have to guess. If you make the table and follow the steps, you'll get the correct answer every time. This technique also works for special cases. Let's start with difference of squares. For our example, we'll use 4x squared minus 9. Now we should recognize this as difference of squares because the first term is a square, the second term is a square, and it is a subtraction or difference. However, if we didn't notice this, we could still factor. We choose factors of 4, 2 times 2, so we have 2x on the left and 2x on the right. In our table, then, we have times 2 and times 2. Now we list factors of 9, and we see here that we'll have to subtract, but we're subtracting to get 0. The middle term is 0, so we look for two numbers that subtract to 0. 2 and 18 don't work, but 6 and 6 do. We took 3 times 2 to get 6 on both sides. So since we're subtracting, one has to be positive and one has to be negative. Since both sides look the same, it doesn't really matter. Let's make the right-hand one negative. And the outside numbers go in our expression. So it's 2x plus 3, 2x minus 3. For perfect squares, we have 4x squared plus 12x plus 9. Factors of 4 might be 2 and 2. So for our table, we have times 2 and times 2. Once again, we list factors of 9. But this time, they have to add to get 12. 2 and 18 don't work, but 6 and 6 do. And looking over here, we see that they both have to be positive. So it's a positive 6 and a positive 6, which means it's a positive 3 and a positive 3. So we put in the 3 and the 3, plus 3 and plus 3, which we could write as 2x plus 3 quantity squared. To get good at factoring, you have to practice, but if you use this technique, you will get the right answer every time.